Hello YouTube, welcome back to the fifth practical in our introduction to statistical analysis with Python. So in this tutorial we're going to look at how to deal with box plots. So if you know what a box plot is, don't worry, we'll go ahead and cover all that process. Okay, so we'll continue with our methodology of our lining approach that we're using. So we get introduced with a question, we learn the concepts to that I need to solve that question, and then we solve a question, we solve that question that we get asked, and then later I give you an assignment to practice your skills. Okay, so we have a question here which is create a box plot to show the age distribution from the age column in the credit data set and state the mean, the max, the first quartile, the second quartile, the third quartile, and the mean of the ages. So if you don't know what the Q1, the Q2 as, the Q3 as, we'll cover all of that just in a second. So let's get ahead and start answering these questions. So let's first look at what a box plot is. So a box plot is also called a whisker plot. Okay, and I'll show much more in details what a whisker is and why it's called a whisker plot. Okay, so a box plot are standardized ways of displaying the distribution of data based on 5 main numeric summaries. So we have the mean, the first quartile, which is Q1, the second quartile, or which is also the median, which is Q3, and then the third quartile, which is Q3. So I have made an error here. So the median is actually Q2, and then finally we have the third quartile, which is Q3. So sorry for that error. And then finally we also have the max. So the mean, the max, the first quartile, the second quartile, and the third quartile, and also the and I also said the mean and the max already. So that's basically it, what a box plot is. Now it might be a bit confusing, don't worry, I'm going to explain this furthermore. So a box plot or a whisker plot, I got this image, and this image source is the link that I have up here. So thanks to the owner who created this image. So this image is actually very easy to understand, and I'm going to use this to explain what a box plot is. So basically what you see up here is basically a box plot. So a box plot has many, this is called the mean, this is called the max value, right? So the mean, the mean value is this way, the max value is this way. So you might ask yourself, what are these additional green points on the left and the right? So these additional green points are called what we call outliers, means the data points that are very far from most of the other observations. So these are called outliers. Okay, so this is the black line here is called the max, and the black line here is called the mean, and then the blue lines here is called the whiskers. That's why it's called a whisker plot. Okay, so in whisker plot we have the other two things. We have the first quarter, which is this line right here. We have the second quarter, which is also called the median, and then we have the third quarter, which is this one right here. So the difference between the first quartile, the third quartile, and the first quartile is called IQR, and IQR stands for Interquartile Range, and we'll look at that more in depth later on. So it's also something, box plot also relates to something called the probability density functions, or PDFs. So this is an example of a PDF behind down here, and this is how a PDF can relate with a box plot. But now we won't be covering PDFs or probability density functions. We will look at them maybe in future videos. I don't know if we'll cover it in this series. I don't think so, but that's basically it, and how a box plot can relate with PDF. So if you guys want me to make a video on PDFs, let me know in the comment section below. I'll do my best to do that. So that's basically what a box plot is. So this is the mean value, which is can also be calculated by taking the first quartile minus 1.5 times the interquartile range, and then the third quartile, which is Q3, can be the max here, which can be found by adding Q3 plus 1.5 times the interquartile range, and the IQR in the interquartile range is the difference between the third quartile and the first quartile, which is basically these values that are within the box itself here. Yeah, and the middle value of the box is called the median. Okay, and this may not be in the middle, it might be skewed to the right, or it may be skewed to the left. So we can also use box plots to determine skewness of data. So I hope that explains to you the basic meaning of box plot and what a box plot is. So we're going to use a box plot to answer our different questions. But first of all, why do you think we need box plot? Let's look at why all the importance of box plots in statistics. So why box plots? So they help to identify outliers. Like if you look here, I told you that these green dots here are called outliers because they're data points that are very far from the rest of the observation, and they can use to check for the skewness of the data. And I told you later on earlier on that the yellow line in the middle is the median value. Sometimes it can be moved further to the right this way, maybe somewhere here, or it can move further to the left this way, the right this way, and depending on that is its means the data is skewed, right? So it can be a positive skew, a negative skew. So we can understand using that. You can determine skewness of data using a box plot. It also helps to determine how tight data is grouped, right? And then it also helps to determine the symmetry of data. Like if the data is symmetrical, means that the median will be exactly in the middle of this box. If it's not in the middle, then the data is asymmetrical, right? It's not symmetric. Then we don't have data symmetry, so the data is asymmetrical. Yeah, so that's one of the common uses of box plots. So that's all we have I made up for box plots. So now let's look at the solution. So look at the solution. Let's take a quicker look at the question before we jump to the solution. So we are going to draw a box plot based on the age distribution, right? We're going to return the mean, the max, the first quarter, the second quarter, and the mean, right? I think this should be the median and not the mean. So I am actually made a typo there. This is supposed to be a median and not the mean. So I hope all that's clear. So great. So now let's go and take a quick look at the solution and how to implement it. So I'm here in my Jupyter notebook, my Google Colab notebook, which is on Google Colab. I'm just so much used to Jupyter notebook. So in the last row, we look at how to plot different pie charts. Okay, so now we're going to look at how to plot box plots. So I'm going to go here and just simply create a text cell below here and just simply call it, give it a title of box plots, just like that. So in here, we're going to go ahead and create a box plot based on the age column. So I'm going to create a simple figure that we're going to simply draw our box plot inside of. So I'm going to say figure, and I'm going to say fig size, and fig size is going to be equals to the following. So I'm going to say 8 by 4. Okay, we're going to have a figure of 8 by 4 dimension. So I'm going to go sns.box plot. So you're going to use something called a library called Seaborn. So we haven't actually imported, that's why we're getting this error. So let me go up here and simply go ahead and import Seaborn. So below our Matplotlib import, you're going to go ahead and import Seaborn as SNS. So I'm going to say import Seaborn as SNS, and then simply run this cell. So don't forget to run this cell. So make sure that you have that cell run. So once we have that, I'm going to go down here, and you can see that error warning is gone, right? So I'm going to say box plot, and then we can simply pass in the x, and x is going to be df, and you're interested in the age column, so I'm going to pass in age, and that's simply going to go ahead and simply draw as a box plot. So I'm going to do plt.show to draw that box plot there. So once this runs, we should have the box plot here. So let me also want to give this a title to make it much more descriptive. So I'm going to say title. The title is going to be age. I'm going to say age distribution with box plots. Just like that. You can give it any title you want, but I'm just gonna go with that specific title. So once we have that, you can see we have a box plot right here. So this is the main value, this line right here, and the line to the far right is called the max, and then these dots are outliers, right? So this one here is called the median, or the middle value, and then this is the first quartile. This line here is the first quartile, and this right here is the second the third quartile. So the difference between the third quartile and the first quartile, which is basically these spaces here, is called the interquartile range, and we went over all of that. So you can see that ages that are starting from around 66, 65 going upwards, the outliers, because they're very far from the rest of the data. Most people are younger than that age, so these are outliers. Okay, so outliers are just data points that are very far from the rest of the observations. So now you can see we have that different data being there, so we can get the information. So we can calculate the interquartile range, we can calculate the different other factors. So we can also do this in another way, which is an easier way of doing it, because sometimes reading this graph can be a bit difficult, right? So like drawing this line here can be a bit difficult, but let me show you another way that we can go ahead and do it. So I can say df, and then I can say age, and I can simply, because we're interested in the age column, and I can simply say describe, just like that. And if I run this cell, once we run that, now you can see I have this right here. So what this basically does, it tells us the mean value, right? The mean value of the data set. The mean value of the data set doesn't necessarily signify the mean inside of this box plot, right? Like if you could trace it here, the mean of this whole data set doesn't determine here, because the mean could be an outlier. Like here, the maximum of the whole age column is an outlier, right? So here. So we also have 25th, which is 25th, which is also called the first quartile. So the first quartile is around 27. This is the second quartile, which is around 33 years old, and then the third quartile, which is the 75th percentile, or 75th 0.75 quartile, which is 42 years old, and the max is 75, and the max actually happens to be an outlier in this case. So basing on, if you remove an outlier and you want to calculate the outlier basing on these box plots, then you have to take the interquartile range, right, Q3 plus 1.5 times the interquartile range to give you the maximum value, which is this right here. And then for the mean, it will be Q1 minus 1.5 times the interquartile range, which is the difference between the third quartile and the first quartile right here. And the mean value right here, the median value right there, is around 34 years of age. So that's basically it, and that the median is also the second quartile, which is around here 33 years old, right? 33. Yeah, so you have answered all that question that we want to do. So you can actually begin to if you want to write, you can write an inference here. You can say inference. Let me just make this be bold, so I'm going to make it bold, and I'm going to simply type in here inference. So inference, like conclusions or key observations, so that you draw from the data. Observations, and I'm just going to list the observations right here. So the first one is that the mean age is around 19, and you can also plug in the formula to calculate, but I'm just approximating it using this graph. So this is around 19 years old. So the max age is around, so you can say the max age is around, let's say 65. 65, like if I bring this around here, it's around 65. Okay, and we can also say let me just state the third observation that I get. So I'm going to say 3, and the third observation is going to be the Q1, which is the first quartile. So Q1 is the first quartile. You can see it is the 25th percentile, so it's going to be 27, and then you can say the second quartile is 33 years old, and then you're going to say the third quartile, which is going to be Q3, Q3, which is the 75th percentile, is around 42 years old. That's basically it. And then you can say the sixth observation, the mean age is around mean age, let's say actually here the mean age is exactly around 35, right? So 35 right here. So if you want to answer the question of the median is going to be the second quartile, which is the median is 33. Okay, you can say years old just to give it units. So year old or years old, just like that. So year old, just like that, and you can decide to add it year old. So year old, so here year old, and also here just give it a unit, so year old. Okay, so once we have all that done, that's basically it, and you have answered all that question that we want to answer. Okay, so we have stated the observations. So now let's go back into the slides and let's see which assignment I have for you guys, so that you guys can practice, right? Because there's no point of learning something if you really don't practice it and master the skill. So let's go ahead and let me show you which assignment I have for you guys. Yeah, so now that we're back to the slide, let's look at the assignment that I have for you guys to practice your new knowledge of box plot. So create a box plot rather to show the credit amount distribution from the credit amount column or the credit amount variable in the credit data set, and state the mean, the max, the first quartile, the second quartile, the third quartile, the mean, and also the median. Okay, something I didn't add here, so you can also state the median of that. So we have covered all of that. So if you guys you're looking for the solution to this, I'm going to leave a link to the notebook that you're going to be using, and you can find the solution to this problem. So the link is going to be in the description. So let me know if you guys have any question or you have any suggestions. I'll do my best to get back to you. Yes, that's basically the question. So in the next video, we're going to look at the practical 6, and the practical 6, you're going to be looking at measures of central tendency. And in practical 6, we're going to be looking at the measures of central tendency. So yeah, that's also what you're going to be covering in the next lesson. So if you guys are new to the channel, please kindly consider subscribing, liking this video, and sharing the content with anyone who you think might find this helpful. Yeah, so thanks for watching, and see you in the next one.